Today I've got another problem from Cambridge University's entrance exam for maths, otherwise known as STEP. Triangle is an operation that takes polynomials in X to polynomials in X. That is, given any polynomial, h of X, there is a polynomial called triangle h of X, which is obtained from h of X using the rules that define triangle. These rules are as follows. Triangle of X equals 1. Triangle of f of x plus g of x equals triangle of f of x plus triangle of g of x for all polynomials f and g. Triangle of lambda f of x equals lambda times triangle of f of x for any constant lambda and any polynomial f of x. And finally, triangle of f of x times g of x equals f of x triangle g of x plus g of x triangle f of x for all polynomials f and g. You can maybe see where this problem's going. Using these rules, we want to show that if f of x is a polynomial of degree 0, that is, a constant, then triangle of f of x equals 0. And therefore, we want to calculate triangle of x squared and triangle of x cubed. Then we want to prove that triangle of h of x is in fact, in disguise, the derivative of h of x for any polynomial h of x. You should make it clear whenever you use one of the above rules in your proof. Pretty cool question. And before I dive into a solution, what I think is quite nice about this is it kind of gives you another way to approach derivatives. So when you're taught, initially taught about derivatives, you're taught, okay, you bring the power down and you get this. And then from that, you kind of prove that, okay, the derivative of x is 1 and the derivative of x squared is 2x and so on. And then you learn the product rule, which is essentially what this guy's saying. What this question is framing it as is instead, if we don't start from that and instead start from things like the product rule and that the derivative of x is 1, we want to show that this is in fact the same thing as just taking the derivative as in the normal sense. Okay, let's dive in. The first thing that we're being asked to do is show that for a constant function f of x, the triangle of f of x is 0. And the way we're going to do this is first showing it for the constant 1. So if f of x is the constant function 1, I'm going to use rule number 4 here. And I'm also going to make g of x equal to the constant function 1. And by just substituting this into rule 4, I'm going to get triangle of f times g, which is just the constant function 1, equals 1 times triangle of 1, plus 1 times triangle of 1. Okay, great. Now, 1 times triangle of 1 is just triangle of 1. That's going to cancel out with that. And I'm just left with 0 equals triangle of 1. Perfect. That's exactly what I wanted to show. I've now proved that the triangle of the constant function 1 is 0. And now what I'm going to do is use rule 3 here. And now replace, if g of x is, let's say, lambda, that's going to be lambda times f of x, where f of x is this function here. And so now, according to this, triangle of lambda is just going to equal lambda triangle of 1, which is 0. And so that proves that the triangle of any constant is 0. Okay, great. Now we want to calculate triangle of x squared and triangle of x cubed. How are we going to do this? Well, this is going to be using this last rule again. Triangle of x squared is the same as triangle of x times x. So I'm going to use my rule 4 now, and I'm going to make f of x and g of x both be x. So this is going to equal x times triangle of x plus x times triangle of x by substituting it into the right-hand side. And I already know from rule 1 that triangle of x is 1. And so this is just going to be x times 1 plus x times 1, which is just going to be 2x. So triangle of x squared is 2x. So this kind of is, on the right lines. We are almost on our way to showing that this is the derivative function. And we can do something similar for triangle of x cubed. So triangle of x cubed, we're going to write this as triangle of x squared times x, which is going to equal to x squared times triangle of x plus x times triangle of x squared. So x squared times triangle of x is 1, so that's going to be just x squared. Plus here I've got x times triangle of x squared, which we've just worked out is 2x. And so we've got 2x squared plus x squared. That's 3x squared, like so. Okay, this is pretty cool. We get this. Now, how do we answer the last part here? We want to prove that triangle of h of x is just the same as the derivative. Well, it checks out for x squared and x cubed. And in fact, you can just proceed by induction here and show that this is true for x to the n. How do we get it then for any polynomial? Well, here's where we are going to use rule two, which we haven't used yet. And this is the fact that we can, rule two, and I guess a combination of rule two and rule three, we're just going to take a linear combination. So basically, rule two and rule three together say that this triangle function is linear. And now, since we can do it for any function x to the n, since triangle of x to the n is the same as the derivative of x to the n, we know that any linear combination of x to the n's will satisfy this equation, and therefore any polynomial h of x will satisfy this equation here. Obviously, in a step exam, you probably have to write that out, but I thought I'd just explain that using words. Thanks so much for watching. I'll catch you in the next one. Have a great day.